HCA is a method in cluster analysis which seeks to build a hierarchy of clusters. There are two strategies for solving HCA. The first one is called agglomerative clustering, which is based on merging. It starts with the points as individual clusters and at each step merges the closest clusters together. The second one is called divisive clustering, which is based on splitting. It starts with one all-inclusive cluster and at each step splits the cluster such that only singletons remain. It must be noted that HCA is often displayed graphically using a tree-log diagram called dendrogram. In this slide, we are going to go through the hierarchical clustering algorithm. At first, we assign each item to a cluster so that if we have n items, we would have n clusters. Then we compute the proximity distance between any two clusters. In the third step, we merge each pair of the clusters based on the proximity measures. Then we compute the proximity measure for the new clusters. We must repeat the steps 3 and 4 until all clusters merge into one big cluster. The key operation of HCA algorithm is the computation of the proximity between two clusters, and it is the definition of cluster proximity that differentiates the various agglomerative hierarchical techniques that we will discuss here. Mean or single linkage or SLINK defines cluster proximity as the proximity between the closest 2 points that are in different clusters, or using graph terms, the shortest edge between two nodes in different subsets of nodes. Alternatively, max or complete linkage or CLINK takes the proximity between two farthest points in different clusters to be the cluster proximity, or using graph terms, the longest edge between two nodes in different subsets of nodes. Another graph-based approach, the group average technique, defines cluster proximity to be the average pairwise proximities of all pairs of points from the different clusters. Prototype-based proximity is the proximity between the centroids of the clusters. The Ward's method attempts to minimize the SSE or sum of squared error between all points and their centroid. In this slide, we can see an example of HCA clustering based on single linkage proximity. Here we can see 6 points, and the Euclidean distances between each pair of the points are shown in the similarity matrix or the table that you can see in this slide. In the first iteration, the minimum distance is chosen in order to put the first 2 points in the same cluster, which is the first cluster. In the next iteration, the distances should be computed according to the previous cluster and the similarity matrix is recomputed. Since we have the single linkage clustering, we must again choose the minimum distance as the next cluster and continue the same way until we have all points in one big cluster. In this slide, we have the example, the complete linkage clustering. The similarity matrix for the first iteration is the same as the single linkage clustering. We find the minimum distance for the first step and form the first cluster. Then in the next iteration, we find the distances according to the previous cluster and choose the point that has the maximum distance from the previous clusters or other points. That is why we call this the max clustering method. In this slide, we can see an example of the group average proximity. In this case, the proximity of two clusters is defined as the average pairwise proximity among all pairs of points in different clusters. The formula of the group proximity is given here in this slide. The denominator shows the number of the points in each cluster. This one also starts with the same similarity matrix in the first step and first iteration. The minimum distance is chosen, and in the next iterations, we find the closest points according to the average proximity. In HCA, merging decisions are kind of final. Once a decision is made to merge two clusters, then it cannot be undone in the future. In addition, agglomerative HCA is expensive in terms of computational storage requirement.